In this video we're going to work through an example of using pandas for data analysis. So we're going to have a data set. I downloaded this data set from Kaggle. Kaggle is a site which has kind of a huge collection of data sets. You can go here. So here's just the kind of beginning of the catalogue. So you can do a search for anything that you want. Say fish, for example. Okay, so you've got lots of data sets of fish and anything else that you might think of. But what we're going to do is this favourite colour report. So people who set up this data set, they made a online questionnaire where people could report what their favourite colour was. And they've got 84 responses in this data set that you can download using this button up here. So here's the data set, which I sort of downloaded separately before. You can see there's a header line at the top. It's a comma-separated values file, so just lines of text. The first line is a header saying what the columns are: country, state or territory, age and years, gender, and favourite colour. We're basically only going to be looking at this last column, which is the favourite colour. But you can see there's all the countries, mostly United States, and some random collection of other things. And then for the United States, there's a specific record for which state in particular. Whereas for other countries, there's nothing in that column. And then the age and gender. But then this last column here is this. There's these strings starting with a hash and then 6 hexadecimal digits. Each of those is a code for a colour. So actually, let's maybe just have a quick look at that. So there's a bunch of different sites you can use to convert hex codes to colours. These are. There's this site called Color Hex. We could try and enter a name here, like say sky blue, and didn't recognise that. Let's try entering purple there, and then it gives us purple and tells us the hex code for purple 80080. We can enter the hex code here, FFFFFF, that's just white. Okay, so we've got, here we see, we've got all these hex codes for different colours down here. Okay, so we want to analyse this, so we can do, we need some imports. Here's the standard imports for NumPy and so on, but we're going to import pandas. Pandas is this kind of standard library for data analysis, various kind of data science processing things. And actually, let's also just, whilst we're here, we'll import sklearn that we're going to need later as well. Actually, that's not quite what we want. We want from sklearn.cluster. Import k-means. Okay, so that's going to help us do clustering, and then we want an extra library that's going to help us deal with color names. Okay, so there's the things we're going to need. Right, so now we need to import this data. Okay, so we're using stuff from the pandas library, which is called PD here. So in the pd.readcsv, that's a function for reading comma-separated value files, like the one we were just looking at, and that's going to produce and the result is going to be what's called a pandas data frame, and it's conventional to call that df. So There's that, and then let's just print the data frame after we've loaded it. Okay, so here you can see it's it's read in the thing, and it gives us the data frame, and by default when we just print it, it gives us the first few lines and the last few lines and little dots in the middle. Okay, so so let's just look at this last column here. So we're going to call it, the way we in pandas we can refer to columns, we just put the df and then the square brackets and then the name of the column inside the quotes there, remembering to use the original American spelling that's in the thing there. And so let's do that, and then we can do FC. So now FC is a, it kind of looks like an array or a list, but morally that's not quite what it is. You can do type FC, it's a pandas.core.series.series, so it's a type that's kind of like a NumPy array or something, but with various extra functionality attached to it. Okay, so okay, so let's take an individual one of these strings like that there. So we need to convert this into a form that we can deal with a bit better. So this is it's a hexadecimal number. It's written in base 16. Base 16, you need digits 0 up to 9, but then you need some extra digits representing sort of 10, 11, 12, 13, 14, 15, and those are written as A, B, C, D, E, F. Okay, so here, for example, we've got 8A, so that's kind of this thing it's a kind of 6-digit hexadecimal number, but it's really 3 separate numbers. So the first one is 8A, the second one is 03, and the last one is 03 as well. And what they mean is that they're kind of the amount of red, the amount of green, the amount of blue. And these are like 2-digit hexadecimal numbers, so they're in the range from 0 up to 16 squared. 16 squared is 256, and in fact you can't quite go to 256. The maximum possible value is 255, which is FF in hexadecimal. Here we've got 8A, which means 8 16s plus A, and the A, remember, is A is 10. You get 0 to 9, then A for 10, B for 11, C for 12, and so on. So we've got 8 16s and 10. 8 16s 128, and the 10 makes 138. So the 8A corresponds to the decimal number 138, and then you've got 3 and 3. So that's kind of 138 bits of red and 3 bits of green, 3 bits of blue. That's what this color means. So we want to actually convert this into three decimal numbers. So C1 colon 3, that just gives us the hash is in position 0, the 8's in position 1, the A is in position 2, and it's the usual kind of Python indexing convention. 1 colon 3 means 1 up to 3, but missing out the 3. You stop just before the 3, so this just gives you characters in position 1 and 2, which is the 8 and the A. So in the same sort of way, we can strip out the 3 different parts of this: the 8A, the 03, the 03. But we want to actually convert this into a normal integer, so which you can do with using int, and then we have to say comma 16 to say we're going to do it in hexadecimal. So that converts the first thing, and then we need to do the same with the other 2. Okay, so that gives us this tuple here. But yeah, we'd actually so we want to do these things sort of separately. So let's just do the red part, the first 2 digits, which give you the amount of red in each color. So we're going to do int C1 colon 3 comma 16. Okay, so so we're going to run through all the colours in this favourite colours column, and we're going to convert the red part for each of them into an integer. So that gives us this list here, list of length 84. Okay. And so we're going to might call that FC underscore R, the red channels in all of these colours. Okay. So that's kind of okay, except that now we sort of detach this thing from our original data frame. It would be better if we could just have these red things kind of as being inserted in part of the original data frame. So the way we want to do that is use this df.assign. Oh, yeah, and then yes, it's the wrong syntax. We have to have equals here. Okay. Okay. So we've apparently done that, but actually, let's just check the data frame again. You can see that if we go back to the original data frame, then this new column doesn't exist. That's because again, this df.assign is creating a new data frame for us. It's not changing the original one. So if we want it kind of incorporated in the original data frame, then we have to sort of assign this new thing to the original variable df. Okay, so now our df has this red column in, and of course we want to do the same thing with the other two. So there's the green and there's the blue, and the green is in characters 3 and 4, and the blue is in characters 5 and 6. Okay, so now we've augmented our original data frame with 3 new columns, giving us the red, green, and blue channels for each of these favorite colors. Okay, so now actually let's look at these favorite colors, and let's just ignore repetitions. And see how many we've got. There's 78. Okay, so we had you had 84 responses in the first place, and between them they've kind of 78 different colors. Right, everyone has chosen very specific colors, and they're almost all different. So we can't really summarize that very much. Yeah, we have to. If we want to make a summary, we need to sort of group similar colors together. So how are we going to do that? Well, that's why we imported this sklearn.cluster thing. That's for clustering data into groups. But we haven't quite got the data in the right form for that yet. We could so for the clustering, we just want to look at these three numerical columns here. So let's separate them out. Okay, so now we've got a list of 3 data frames. But let's or 3 series. Let's just get rid of the kind of extra pandas wrapping and just convert it into a normal array. Okay, so now to a normal NumPy array with 3 rows, each of length 84. The first row contains all the red information, the second row contains the green information, and the last row contains the blue information. But that's still kind of not quite what we want for the clustering mechanism. For that, that instead of having a 3 by 84 matrix, we need one that's 84 by 3. So we just do this .t thing on the end to transpose it. So now we've taken the transposed matrix, and now each row is the red, green and blue channels for a particular respondent to this survey. Okay, so let's give this guy a name. So this is our color matrix. Okay, so now we need to do this clustering thing. So the way we do that, well, firstly we need to decide how many clusters we're going to make. So we can just sort of choose randomly and maybe adjust it if necessary. Let's maybe try and divide our people into 6 groups. Okay, so let's n equals 6. That's the number of clusters we're going to do. And okay, so we've got this k-means in capital, so that's the thing we imported. That's really referring to sklearn.cluster.k-means. sklearn is scikit-learn library. That's a big machine learning library for Python. And so one aspect of the whole machine learning story is this k-means clustering algorithm, which we're not going to explain here. You can find all sorts of information about the k-means clustering algorithm on the internet in different places. But here we're just going to use it. And the way we use it, we do this first line here doesn't really find the clusters, but that's just kind of setting things up. It creates this object called k-means in lowercase, which is a cluster finder, and then we're going to apply this fitting thing to the color matrix, which is going to divide our color matrix into 6 clusters. And then it produces this kind of little box here, which is not very useful for us, so let's hide it. If we just put none at the end, then that will just suppress the useless output. Okay, so what have we got in these as a result of this? So let's actually do dir k-means. That tells us everything that's in this kind of k-means object. So there's all these kind of things with double underscores. They're not really double underscores or single underscores at the beginning. That's actually not very relevant. The things we really care about is the stuff that we've got at the end, the inertia, the labels, n clusters, these kinds of things here. It's actually mostly this thing here, the labels entry, which is what we're looking at. So let's ignore that, and let's just look at k-means.labels underscore. So this is an array of length 84, and it contains a number in the range 1 up to 5 for each of the respondents, and that's telling us which cluster they're in. So the first respondent and the third respondent are in cluster 0, and then this guy also in cluster 0, and then second respondents in cluster 1, and then these ones here, 4th and 5th, are in cluster 2, and so on. Okay, so so let's actually put this back in our original data frame as well. So okay, so now we've put this cluster index column in the end here. So each of these things that you see here, cluster 1 is this. This person's in cluster 1. Their favorite color is like this, with no red, no green, and quite a lot of blue. So that's roughly what your cluster 1 is going to be.
Okay, so now we need to work out what are these clusters? What colours do they represent? So we can do that. We can look at cluster centres. Okay, again, a situation we need to use the American spelling of centre. Okay, so we get so we divide it into 6 groups, 6 clusters here, and then for each cluster we've got a vector of length 3, which is kind of telling us the color proportions for each cluster. So this first cluster is like a red value of 40, a green value of 130 and a bit, and a blue value of 178 and things. But we really did, so these are floating point things, but most of the sort of things that deal with colors can't deal with floating point numbers. They have to have integers. So let's apply np.rint, which rounds everything to integers. We've got this like this, but notice though that we've got integers, but they've all got these kind of decimal points on the end. They're sort of officially floating point numbers that happen to be integers. That's kind of not quite what we want. It would be tidier to make them sort of be proper official integers. So we can do this as type int thing. Okay, so now we'll use the decimal points. These are actual real official integers. But we want to get back to these kind of hex code things. So how do we get these back to hex codes? So for each of this thing here, we're supposed to think of this as morally being in sort of base 256. So these are units, these are 256s, and this is kind of morally multiplied by 256 squared. So we can do that by as a matrix multiplication. Okay, so we take this matrix here and multiply it by the vector 256 squared, 256, 1, and everything in this column gets multiplied by 256 squared, everything in this column gets multiplied by 256, everything in that column is multiplied by 1. So this gives us an array of individual numbers. Okay, and then our problem is to write these in hexadecimal. We can do that using a formatting string. Okay, so we let D run through this list that we just made, and then we're going to convert it to a string using this the format for specifier :x, which means we want hexadecimal. Okay, and so that worked. Actually, it kind of wasn't guaranteed to work, because we might have needed some extra zeros at the beginning just to pad it out to make sure it has links. So we'll just put in an 06 there. In fact, in this instance, it doesn't make a difference, but that would give us extra zeros on the beginning to make sure we had a string of length 6 if necessary. And also, we want to put the hash back in here, so we can put the hash there as part of the format string. Okay, so there's so this now is the hex codes for the sort of central colors of all our clusters. So let's give this thing a name. We'll call it the cluster colors. Okay, so those are hex codes. It would be nice to actually have names for them, and to find names for colors, well, that was what we imported this colory package for. So okay, so here's the colory package on GitHub. So this is actually a kind of nice small package, which you could actually just read the code and see how it works if you want to play around with that a bit. but so we can so let's just put in a random hex code and it produces a color object. If we do .name, then it gives us a name for that color. So apparently this is called wine red. Let's change it. So that's called dark purple. Okay. Okay, so let's convert all these cluster colors to names. Okay. So yeah, this is a set of names, but actually you get different options for which kind of basic source of color names you're going to look for. I would prefer to use this thing, the XKCD list, which gives me these names here instead. Okay, so this is XKCD list comes from this page here. It was a very large survey of asking people what they think colors should be called, and came up with this table here. Okay, so going back to here, so here are the XKCD colors for these XKCD color names for these various colors. So let's put them. Okay, so we've got the hex codes and the names for these things. But then we also need to know, how many people there are in each cluster. So we have this. This was our series of indices, and we need to just check how many of each, how many times there's a 0 appears, how many times 1 appears, and so on. And there's a convenient function for that called np.binCount. So that produces an array of the counts. Okay, so let's. So let's call that cluster counts and put this in here as well. Okay, so now we've got the colors, the names, and the counts, and now we can try and plot these. Okay, so we can make a bar chart. Okay, so we could here's a bar chart. So here we've got the hex codes along the bottom, and then the sizes of the bars indicate how many people there are in each thing. It would be better if instead of just making all these blue, we just made them equal to the coloured them according to the colours they actually represent. So so we can do that just by specifying the colour argument there. And we could also, instead of we could just do the names instead. So unfortunately, the names are a bit long; they sort of overlap. One way we can get around this is by sort of making them vertical. We can't make them vertical sort of just by putting them in here. We have to sort of do a slight dodge. So we can just do. Initially, let's just label these by numbers. So. So now there's that. Then we're going to we're going to add the labels using the kind of xticks method. So we're going to put the markings on the x-axis like this, and then the labels are going to be like that. But here we can put in a rotation parameter to turn the labels around and make them vertical. Okay. And so now that's done what we want, except yeah, we've got this kind of useless stuff here that we don't really want to see, so we just put none in there, and we suppress that, and now we've got our bar chart as expected. Alternatively, we could do a pie chart. Okay, so here make a pie chart here that just gives us a random pie chart. Let's actually put in the none again. Okay, but that doesn't tell us what the slices in the pie chart are. So now let's label them like that. But now, again, you see the it's just chosen the colours randomly. So this is supposed to be dark purple. It's actually coloured orange. So we need to provide the colours here. Yeah. So there's a bit of a difference here in the bar chart thing. The parameter is called colour, and here it has to be called colours. So that's just life. So now we've got a pie chart with everything labelled in the expected way, and that will conclude our exploration of pandas.